Hi, my name is Mukund Krishna. I am managing product marketing at Empower Semiconductor, and today we'll talk about the Crescendo solution, especially the thermal benefits of the solution and why it matters in the system. So to start off, this is the Crescendo power solution here, really showcasing vertical power delivery. This is shown in an array of 16, which is a 1000 amp domain. And here you can see that each of these devices have a thermal interface. It's a copper interface. And the main benefit here to that is we can now get a 1 degree C per watt thermal resistance from the silicon die out to the cold plate. So this is showing a thermal simulation of a TDC, or a thermal design current solution, right, where each of these devices is dissipating about 5 watts internally. And it's a very high thermal stress environment where there's an XPU or a GPU on top. The PCB is operating at a high thermal environment, about 80 degrees C, that's typical. And so there's power dissipation not just in the power module or our Crescendo module, but also in the PCB. And the thermal resistance from the PCB all the way to the cold plate is about less than 3 degrees C per watt. And so what that means is that we're pulling heat not just out of our own devices because of the backside, thermal solution, but we're also pulling heat out of the PCB, which otherwise is kind of sandwiched between two, heat sources, if you will. On one side, there's a big GPU that's hundreds or thousands of watts, and on the other side, there's a power delivery system that's dissipating hundreds of watts as well. And so this is a really beneficial piece of the thermal resistance of the Crescendo solution. So the reason the thermal resistance matters is because to achieve the power density, you need really good thermals to go along with it. Because if you have a really high power density module, but you don't have a good thermal interface or a solution to go with it, that means it's going to get extremely hot and reach its limit. So for example, 100 or 125 degrees C. And the closer you get to that, the less power you can actually deliver to the system. So that's why you need to be able to get that heat out, allow that power delivery system to operate in a reasonable thermal environment so that it can actually deliver that power, and then that's how you get that power density. And then going as a preview to our next generation, we're getting about 3 times the power density from our existing Crescendo solution. So that's hitting about 5 amps per millimeter square in terms of peak power density. And to go along with it, to my earlier point, we have a thermal interface that will be less than half a degree C per watt. Right? So it's a 2x better thermal interface that we'll get with a 3 times higher power density. Right? So that's where we're going with our Crescendo solution. We're tackling the whole thing as a solution, not just for density, but also for thermals.